Welcome back, my dear friends. I have already shared the previous syllabus which are going to study in this strength of material subject. So अगर आप पहला वीडियो नहीं देखे तो आप लोग जाके देख लीजिएगा ताकि आप लोग का कंसेप्ट हो जाएगा कि हम लोग क्या क्या पढ़ने वाले स्ट्रेंथ ऑफ मटेरियल में. So let's start the lectures. The strength of materials is a branch of subjects or the branch of mechanics in which we are especially dealing about the behavior of the deformable body under the action of the different types of loading taking place. So I have already told you that is what is the deformable body. There is a deformation taking place or there must be the change in dimensions. That is nothing but the deformable body, the body which deforms under the action of the load. So चलिए शुरू करते हैं हम लोग. आज पहला टॉपिक है सिंपल स्ट्रेस एंड स्ट्रेन. The most of the students have doubt on the stress. They may be thinking about that the stress is external force or load. No, my dear friends, it's not like that. So stress is nothing but the internal resisting force per unit area. I means let us imagine आप एक रेक्टेंगल बॉक्स या तो आपका हाथ में पेन है, मान लीजिए पेन है. When we apply to equal and opposite pull forces on the pen, then there must be a deformation taking place. Either it may be negligible क्योंकि हम लोग उतना जोर नहीं लगा सकते, but there is a deformation taking place while you apply the great forces. जब बॉडी को खींचते हैं, उसको तनकाते हैं बाहर की तरफ, then there is either बाहर की तरफ तनकाइए और भीतर की तरफ ले जाइए, then there is a change in dimensions. तो जब हम लोग बाहर की तरफ खींचते हैं, then there is a resisting force inside the body which resist of deformation. जो डिफॉर्मेशन होने से रोकता है उसी को स्ट्रेस बोलता है. फिर से जब कोई भी बॉडी को लोड लगा के उसको बाहर की तरफ या अंदर की तरफ खींचता है, then the force which generate inside the body to resist or to counter attack the external load, that is nothing but the stress. So stress is not an external load, it is an internal resistance, the internal resistance which the body offers. What offers? The body offers when the body is subjected to the load. So the internal resistance which the body offers to meet the load or to counter attack the load, to keep the body in equilibrium states. So if someone told you that the stress is the external load, not, it is an internal resistance which a body offers to counter attack the load. Here the terms load comes. My dear friends, load is nothing but the external force which is acting on the body. Any external types of force which is, suppose we are pushing the wall, that is nothing but the load, because here applying we are external loads. So sometimes the external load is also termed as the mechanical force. Mechanical force is nothing which need to be direct contact on the body, or the external force acting on the body directly. We are making the contact of the body directly under the action of the external load. So when the body is subjected to when a body is subjected to under the load or external force, then it must go under the deformations. आप लोगों को पता है जब कोई भी बॉडी पे लोड लगाते हैं तो वहाँ पे चेंज इन शेप एंड साइज होता है. तो जो चेंज इन शेप एंड साइज होने से रोकता है एक अंदर की तरफ, एक अंदर का फोर्स, वही होता है स्ट्रेस. सपोज मान लीजिए दिस इज अ रेक्टेंगुलर सेक्शंस व्हिच इज सब्जेक्टेड टू टेंजाइल stress or tensile forces. When the body is subjected to tensile stress and or either the compressive stress, then I have cut the sections XX. So the sections which is left to the crossing section XX applying P, then there must be a resisting force. मैंने आपको बोला था जो अंदर की तरफ एक इसको रोकता है, then there must be a resisting force F. That resisting force per unit area of the cross sections is termed as the stress. So we can simply define the stress as the internal resisting force per unit area is known as stress. Or if you know the real meaning of the stress, you can define in your own way. The resistance offered by the body to counter attack the load, that is nothing but the stress. So if you have the practical levels of any theoretical terms, we can term that term in our own way. So my main concept is to connect you what we are reading to the practical level. So that must be the useful, otherwise there is no way to study. If we memorize any terms, that is useless. So we must connect what we are studying to the practical level. So stress is nothing but the internal resisting force. आप ध्यान से इसको समझ लीजिएगा कि एक इंटरनल रेसिस्टिंग फोर्स है, ये कोई बाहर का फोर्स नहीं है, ये इंटरनल रेसिस्टिंग फोर्स है जो लोड को काउंटर अटैक करता है, वही होता है स्ट्रेस. सो मान लीजिए व्हेन द बॉडी, आई हैव टोल्ड व्हेन द इंटरनल रेसिस्टिंग फोर्स अपोजिंग द external loads, then there must be summation of fx is equal to 0, then f minus p is equal to 0, then f is equal to p. So ultimately simple here is the stress resisting force per unit area. As you know, the simple stress is often called as direct stress. Either we can term it as stress, simple stress or direct stress, both are same. The direct stress acting exactly on the central of the neutral axis. Later we will discuss about the eccentricity or the load which are acting beyond the neutral axis. Later we will discuss about all these things. Here we are only concentrating about the direct stress. So direct stress exactly acting on the center of the neutral axis, means on the line of the neutral axis, not away from the neutral axis. So stress is denoted as sigma, and it is equal to P by A or F by A, the resisting force per unit area, not the load by area. So the units of the stress depends upon the units of the force or the unit of the cross section area. The unit of the force is Newton, sometimes maybe kilonewtons, or the unit of the area maybe a square meter, a square centimeter, a square mm. It depends upon the size of the sections. So its SI unit is Newton per meter square. It is also termed as 1 Pascal or Newton per mm square. So my dear friends, यहाँ पे एक और interesting term है, stress is a tensor quantity. If someone asks you either stress is a vector quantity or a scalar quantity, no, neither it is a scalar quantity nor it is a vector quantity. It is a tensor quantity. This is so because in a vector quantity it must consist of magnitude and direction. Similarly, in a scalar quantity, it is consisting of magnitude. But stress is a tensor quantity. It consists of magnitude, directions, and must neither a plane. The stress is acting in all these three criteria. It must consist of magnitude, direction, and plane. So stress is a tensor quantity. Later we will discuss in a brief manner why it is a tensor quantity. What is a tensor quantity? Tensor quantity is nothing but it's simply following the algebraic additions law. So later I will tell you what is tensor quantity. Here the just need to be understand is that a stress is a tensor quantity or stress is an internal resisting force. Let's discuss about the units of stress because it is very important. Most of the students are doing wrong while converting the unit from one to another. So it is very essential to have a clear knowledge on the units of stress. The units of stress depend upon the unit of load or force and or the unit of area, as I have told you. So let us take the examples. 1 Newton per meter square. Say 1 Newton per meter square is a units of stress. So if you convert it into the centimeter square, 1 Newton per centimeter square, then 1 Newtons here per means divide, or 1 meter square if you change into centimeter square, then there is a multiplication of the 1000 into 1000 because meter square to centimeter square. Then 1 divided by 1000 into 1000 equal to 1 into 10 to the power minus 4 Newton per centimeter square. Similarly in mm square, 1 into 10 to the power 6 mm square. So from the above calculations we can conclude that 1 Newton per mm square is equal to 10 to the power 6 Newton per meter square, which is also equal to 1 Pascal, or it is also termed as 1 mega Newton per meter square. So कहीं भी क्वेश्चन में जब 1 मेगा न्यूटन पर मीटर स्क्वायर रहेगा, don't be afraid. it is also equal to 1 Newton per mm square. So we must have a lucid knowledge in all these things, and we must have a clear or knowledge in all these things, so that we may not going to do the mistakes in the numericals, because it is very, so we have a good knowledge on the conversions. 1 mega Newton per meter square, 1 mega Newton per meter square is also equal to 1 Newton per mm squares from the above calculation. Similarly, 1 giga is nothing but the 10 to the power 9 newtons. So tera is nothing but the 10 to the power 12 newtons. So these are the terms to be remembered while doing the conversions. So hope करता हूँ आप लोग गलती नहीं कीजिएगा ऊपर का टर्म से. So well, अभी तक आप लोग का स्ट्रेस के बारे में अच्छा खासा प्रैक्टिकल नॉलेज हो गया होगा. आप प्रैक्टिकल लेवल पे रिलेट कर सकते हैं इसको. सो चलिए अब हम लोग बात करते हैं स्ट्रेन का. सो लेट्स स्टार्ट एंड टॉकिंग अबाउट द स्ट्रेन. माय डियर फ्रेंड्स, if is in the simple way, if you define the strain, a strain is nothing but the measurement of deformations. And what is deformation? Deformation is nothing but the change in dimensions of the body. So if there is a change in dimension of the body needs to be measured is known as strains. Or we can also define the strain in this way: the ratio of change in dimensions, or the ratio of change of dimension of the body to the original dimension is known as strains. The strain is produced due to the action of the stress. So when a body is subjected to external load, there must be some changes of dimension of the deformable body. Either we can visible by our naked eyes or not, but there may be a microscopic levels changes. So the change in dimension of the body by the original dimension is nothing but a strain. मान लीजिए कि आपके पास कोई रेक्टेंगल शेप का बॉडी है, कुछ भी है, जब आप लोग उस पर फोर्स लगाएंगे या तो अंदर के तरफ या तो बाहर के तरफ, तो जब बाहर के तरफ या अंदर की तरफ फोर्स लगाएंगे देन द बॉडी गोज अंडर डिफॉर्मेशंस. देयर इज अ चेंज इन लेंथ, then how much amount of deformation taking place, that divided by the total length of the body is nothing but the strain. So the dimension of the strain is dimensionless. So strain does not have any units, it is dimensionless and it is denoted as E, small e. So strain is nothing but the change in length by original length. आप ऊपर वाला फिगर से देख सकते हैं, एक रेक्टेंगल सेक्शन है एल का, उस पर टेंजाइल फोर्स लगाए, द फोर्स लगाए तो वहाँ पे कुछ चेंज इन लेंथ आया डेल एल, तो जो डेल एल आया डेल एल बाय एल इज नथिंग बट द स्ट्रेन. होप आप लोग को क्लियर हो गया होगा स्ट्रेस और स्ट्रेन क्या होता है. चलिए बात करते हैं टाइप्स ऑफ स्ट्रेस. नाउ वी विल टॉक अबाउट द व्हाट आर द टाइप्स ऑफ स्ट्रेस. Now there are the three types of stress: tensile stress, compressive stress, or the shear stress. Now here the term to be understand is tensile stress. It is very familiar to our day-to-day life. Tensile stress is nothing when the body is subjected to two equal and opposite pull forces. Imagine you have a rectangular shape of body in your hand. Or imagine you have a strip of papers in your hand. When the papers, if you pull the papers to the externally, if you apply the load on the paper to equal and opposite pull forces, then paper must go under the tears. जब हम लोग पेपर को बाहर की तरफ खींचेंगे तो पेपर वहाँ पे फट जाएगा. But before tearing, there the body must undergo the body must goes under certain deformations. उसको फटने से पहले वो कुछ सर्टेन डिफॉर्मेशन में गया था जो हम लोग बाहरी आँख से देख नहीं सकते, बट बॉडी मस्ट बी अंडरगो सर्टेन डिफॉर्मेशंस. सो दैट इज नथिंग बट द टेंजाइल स्ट्रेस. वही द टाइप्स ऑफ स्ट्रेस इन विच अ बॉडी इज सब्जेक्टेड टू टू इक्वल एंड अपोजिट पुल फोर्सेस. देन to resist or to counter attack these pull forces, there must be generate resisting forces. As I have told you that when any body is subjected to load, then there must be a counter attack internal forces, that is nothing but the stress. Similarly here the type of stress which is developed is to equal and opposite pull. F is nothing but the resisting force. So tensile stress is nothing but the resisting force by cross section area. So stress is denoted as sigma equal to P by A. Now here next, compressive stress. It is quite opposite of the tensile stress. In tensile stress we are applying to equal and opposite pull forces. Here we are applying push forces. The compressive stress, column or the beam or the column and the pillars, column or the pillars are under the compressive stress or the compressive load. हम लोग घर में जो column और beam होता है वो maximum compressive ही status में होता है. So the type of stress in which a body is subjected to equal and opposite pushes force. So here I have taken a sections which is under the application of the opposite pushes forces. Then there must be a resisting force to counterattack the external load which is coming toward the pushing manners. So there generated a resisting force. So compressive stress is given by resisting force by area, push by area. Here now tensile is nothing but the two equal and opposite pull forces are undertaking. Here push forces are undertaking. So now the term to be understand, the tensile stress are means the rope of the cranes is under the tensile stress. The column or the pillars are under the compressive stresses. So now here the term shear stress. Most of the students have not well concept about the shear stress, or they may not think about the practical level of the shear stress. So don't worry my dear friends, I will tell you in simple manner what is shear stress. See, shear stress is also types of stress in which a force act tangentially to the cross section area of the body. कोई भी बॉडी पे फोर्स टेंजेंटियली मैनर में लगता है उसी को shear stress बोला जाता है. अब फिर से समझ में नहीं आया तो मानिए आप पेंटिंग, जब हम लोग पेंटिंग करते हैं तो वाल पे देन देयर इज अ जनरेटिंग टू इक्वल एंड अपोजिट टेंजेंटियल फोर्सेस. वी आर अप्लाइंग टेंजेंटियली टू द सरफेस while we are painting. So painting, chewing food under the teeth, brushing, tearing the paper with the scissor is all those are the example of the shear stress. While we are running the foot under the road, there exit the foot under the surface of the road, there must be applied tangential force. Then these all are the shear stress. In our day-to-day life, the shear stress is most familiar and the most seen types of stress. In everywhere we confront with the shear stress. So shear stress is nothing but the type of stress which act tangentially to the surface. So let us take, imagine कीजिए कि आपके पास एक ABCD कोई rectangle sections है, ABCD कोई rectangle section है, and the end of AB is fixed to the surface while the CD is free to expose. So imagine कीजिए एक बॉक्स है, ए बी फिक्स्ड है. जब while we are applying the force tangentially on the surface CD, while we are applying force tangentially on the surface of CD from D to C, we are applying force tangentially from D to C, then there must be generating a resisting force which counter attack the tangentially force. So there must be a force from C to D to counter, there must generate a resisting from C to D to counter attack or to keep the body in equilibrium. So this is nothing but the shear stress. आप लोगों को अच्छे से समझ में आ गया. आप shear stress क्या होता है, खाना खाते हैं वो भी shear stress वहाँ पे रहता है, ब्रश करते हैं, पेंटिंग करते हैं, जब हम लोग दौड़ते हैं etc. all those are familiar with the shear stress. Now we will talk about the types of strain. Well, I have already told you what is strains in clearly. So here these are the types of strains: tensile strains, compressive strains, shear strains, and the volumetric strains. Tensile strains, it is nothing but the change in length to the original length is known as tensile strength. When the body is subjected to under the action of pull forces, the body must go under the deformations. वहाँ पे जब हम लोग कोई भी बॉडी को फोर्स लगाएंगे तो वहाँ पे चेंज इन लेंथ होगा. दैट चेंज इन लेंथ इज ड्यू टू द टेंजाइल स्ट्रेस. दैट इज नथिंग बट द tensile strength. So tensile strength is denoted as a small e equal to increase in length, that is del L, how much length is deforms or how much length is increased under the action of the tensile stress. Or we can also define the tensile strength, the strength taking place due to the tensile stress, or the strength corresponding to the tensile strain corresponding to the tensile strength is known as tensile strain. So tensile strength is equal to increase in length by original length, that is del L by L. Now we will deal about the compressive strength. It is quite opposite to the tensile strength. It is while we apply the compressive stress, the body, the shape and size of the body decreases, or there may be decrease in the length. So the ratio of decrease in length to the original length is known as compressive strain. So this is due to because of the compressive stress. So in these figures I have also explained, when the body is subjected to compressive stress, then there is a decrease in length, that is del L. Decrease in length del L by L is nothing but the compressive strength. Now the term shear strength. My dear friends, I have already told you that the AB is a fixed end. Imagine while we are applying the load under the surface of CD, which is acting tangentially. Remember one thing, that A and B is a fixed end. There is no deformation taking place on the end of AB. So we are applying tangentially force under the surface which is exposed, that is CD. Then we are applying certain tangential force, then the body distorts, or there is a formation of the angle by which the body distorts. So while we applying the shear load, the shear strain will be produced. How the shear strain will be produced? Shear strains will be produced under the action of the shear load, and there is the formation of the angle by which the body distort. So the angle is nothing but the phi. Here initially the shape of the body is A, B, C, D. When the tangential force applied, the D tends to change towards the D dash. Similarly the C tends to change C dash. So the D to D is del L. There is a certain change in length, or there is an angle formation, that is phi. हम लोग इसको इमेजिनेशन भी कर सकते हैं, ठीक है. ऊपर से हम लोग लोड लगाए, देन क्या होगा, वो बॉडी टेढ़ा हो जाएगा, देन वहाँ पे तो एंगल फॉर्म हो. जब बॉडी उस पर फोर्स लगाएंगे तो बॉडी थोड़ा सी से डी से लेकर सी के तरफ हम लोग फोर्स लगा रहे हैं, तो उसके तरफ बॉडी झुक जाएगा. मीन्स देर इज कुछ चेंज होगा, और कुछ एंगल इनिशियली से कुछ चेंज हो जाएगा. समझ रहे हैं ना आप लोग. तो वहीं जहाँ पे एंगल फॉर्मेशन होगा फाई, दैट इज नथिंग बट द shear strain. सो shear strain इज नोटेटेड एज फाई, दैट इज इक्वल टू डी बाई डी डैश बाई ए डी. डी बाई डी डैश इज द चेंज इन लेंथ बाय ओरिजिनल लेंथ, दैट इज del L by H. Similarly C to C dash by H, and these are the shear strains. Now talk about the volumetric strains. Volumetric strain is nothing but the ratio of change in volume to the original volume of the body, that is nothing but the volumetric strain. Volumetric strain is denoted as AV, that is change in volume by original volume. Suppose take one example of balloons. While we are applying the force under it, either may be compressive or any, while we are applying the force on it, with the volume of the balloon changes. When you release the forces, again the volume of the changes in volume by original volume is nothing but the volumetric strain. So the volumetric strain is the ratio of change in volume to the original volume. So I hope I have cleared you the doubt regarding about the simple stress and the strains. So अब आप लोग का कोई डाउट नहीं होगा, शायद होप करता हूँ क्लियर हो गया. अगर कोई डाउट होगा देन कमेंट सेक्शन में आके कमेंट कीजिए, आई विल क्लियर दैट डाउट. नाउ हियर द टर्म टू बी अंडरस्टैंड इज इलास्टिसिटी एंड प्लास्टिसिटी. Well, my dear friends, these are the very familiar terms in our day-to-day life. Elasticity is nothing but the property of the material. It is the property of the materials when the load is applied on the body, it regains its original shapes after the removal of the body. ये इलास्टिसिटी एक ऐसा बॉडी का प्रॉपर्टी और ऐसा एक मटेरियल का प्रॉपर्टी है, जब हम लोग उस पर एक्सटर्नल लोड लगाते हैं तो उसका सर्टेन चेंज होता है, उसका शेप एंड साइज, उसका डायमेंशन चेंज होता है. लेकिन while we remove the external load, the body regain its original shapes. If you take about the real time example of the elasticity, then a rubber band, while we apply the external force on the rubber band, there is a deformation taking place, but while you remove the external loads, the body again comes under the elasticity property. So elasticity is nothing but the property of the material which undergoes certain deformations, and while the removal of the load, it must be regain its original shape and size. Similarly, we will talk about the plasticity. Plasticity is opposite of the elasticity. It is also the property of the materials. Once the load is applied on the materials, the body undergoes certain deformation but cannot regain its original shape and size. That is nothing but the plasticity. So plasticity deformation is observed in most of the materials. Like in our day-to-day life, the most of the materials are plasticity. Once the load is applied and after the removal of the load, there is no regainations properties of the material consisting of. So plastic deformations are like steel, soil, like wood, etc. are the example of plasticity. While on the wood, while you apply the forces, it must undergo certain deformations, but while the removal of the external load, the body cannot regain its original shape and size. So don't be confused between the elasticity and plasticity. Now we'll talk about the very important terms, elastic constants. It is very important for the university perspective or the competitive exams. There must be a multiple choice questions which are asked related to these terms. So elastic constant is E, K, G or mu. So let us talk about the E, modulus of elasticity or Young's modulus. Young's modulus is also known as modulus of elasticity. Young's modulus is nothing but the tensile stress and the tensile strength. It is the ratio of tensile stress to the tensile strength, or maybe the compressive stress to the compressive strength. Remember, modulus of elasticity or Young's modulus is defined as the ratio of tensile stress and tensile strength, or compressive strength and compressive stress and compressive strength. It is denoted as capital E. So we can term it as E equal to sigma by small e, that is simple stress or the tensile stress by tensile strength, or equal to, that is ET, that is tensile stress by tensile strength or compressive stress by compressive strength. So ultimately we can say that E equal to stress by strength. It is defined as the ratio of stress to the strength, either it may be compressive or tensile. So my dear friends, Young's modulus or modulus of elasticity is very important terms. See, the more value of E indicates the body's more rigidity. See, if the Young's modulus of any material, imagine कीजिए कि कोई भी वस्तु का Young's modulus अगर ज़्यादा है, इसका मतलब ये हुआ कि उस बॉडी का डिफॉर्म करना उतना ही डिफ़िकल्ट होगा, क्योंकि स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू Young's modulus is directly proportional to stress. So the more value of Young's modulus indicates the more rigidity, or rigidity means the difficult to penetrate or difficult to deform. So यहाँ से क्लियर ये होगा कि जो E होता है वो जो जिस भी वस्तु का वैल्यू E ज़्यादा होता है उसका डिफॉर्म करना उतना ही डिफ़िकल्ट होता है. मान लीजिए आपके पास एक रबर है और मान लीजिए आपके पास एक पेन है. रबर को डिफॉर्म करना इजी है. व्हाई इट इज इजी? बिकॉज द वैल्यू ऑफ Young's modulus ऑफ E इज लेस कंपेयर टू दैट ऑफ द पेन. और मान लीजिए पेन को डिफॉर्म करना, और इट इज़ वेरी डिफिकल्ट टू डिफॉर्म द पेन्स बिकॉज द वैल्यू ऑफ E इज मोर ऑफ द पेन कंपेयर टू द रबर. So keep in mind the value of E indicates the more rigidity of the materials. So Young's modulus is measure of the stiffness. Well, stiffness is nothing but the deflection per unit length. So the Young's modulus is the measures of the stiffness. Stress is inversely proportional to the strength. The more value of Young's modulus or indicates the less value of strength. Where the Young's modulus have more value means less deformations taking place because it is directly proportional to the stress. More value of Young's modulus means more value of stress. That means the body is more rigidity or more difficult to deform. So hope आपका कंसेप्ट पूरा हुआ होगा modulus of elasticity or Young's modulus. This modulus of elasticity is nothing but the ratio of stress by strength. Either it may be compressive or tensile. So next terms we will deal about modulus of rigidity or the shear stress. Modulus of rigidity is also termed as shear stress. Here the ratio of shear stress to the shear strength. In modulus of elasticity we deal about the compressive stress and tensile strength. So here we are dealing about the shear stress or the shear strength. So the ratio of shear stress to the shear strain is nothing but the modulus of rigidity, or modulus of rigidity is also termed as shear modulus. It is denoted as, in some of the textbook it is C, in some it is N, or some it is G. So don't be confused. C and G, it is denoted as the modulus of rigidity. So it is shear strain, that is tau by shear strain, E small s, or it is also as phi. So modulus of rigidity or shear modulus is the same terms. Now bulk modulus of elasticity. Well, my dear friends, bulk modulus is nothing but the ratio of normal stress on each face of the solid cube to the volumetric strength. Here the term to be understand is what is normal stress. So normal stress is nothing but the stress which is acting perpendicular on the surface of the body. Once again, normal stress is nothing but the type of stress which is acting perpendicular, that is exactly 90 degree to the surface of the body, that is normal stress. So the normal stress on each face of the solid cube. Suppose we have a solid cube A, B, C, D, E, F, G, H. We have a solid cube, imagine. Then the normal forces acting on each faces, either in A, B, C, D or E, F, G, H, in each side, the normal force acting to the volumetric strain, what EV, and I have already explained you what is volumetric strain, the change in volume by original volume, remembered. So bulk or volume modulus of elasticity is nothing but the normal stress acting on all faces of the solid cube to the volumetric strain, that is sigma n, that is normal stress, by EV, that is volumetric strain. Now here the Poisson's ratio, it is very important terms in the materials, in the strength of materials. My dear friends, Poisson's ratio is nothing but the lateral strains to the linear strains. Here linear strain is nothing but the longitudinal strains. चलिए आप इमेजिनेशन कीजिए, आपके पास ए बी सी डी ई एफ जी एच एक रेक्टेंगुलर क्यूब है. वी हैव रेक्टेंगुलर क्यूब व्हिच वी कैन डिफॉर्म इजली, जिसको हम लोग डिफॉर्म इजली कर सकते हैं. मान लीजिए इसमें जो फोर्स लगाए पी एक्स एक्सिस में, मान लीजिए कि उसको हम लोग एक्स एक्सिस में अगर टेंजाइल फोर्स लगाएंगे तो एक्स एक्सिस के तरफ बढ़ेगा, लेकिन एट द सेम टाइम वाई एक्सिस और जेड एक्सिस में क्या होगा, कम होगा, उसका डायमेंशन क्या होगा, कम होगा. आप इमेजिनेशन कीजिए कि आपके पास कोई रेक्टेंगुलर क्यूब है जो इजीली हम लोग डिफॉर्म कर सकते हैं व्हेन वी आर अप्लाइंग टेंजाइल स्ट्रेस इन एक्स एक्सिस. then there is a elongation taking place in x axis, at the same times there is a decrease in its other two lateral dimensions, that is lateral strain. So जब हम मतलब कोई भी अभी मतलब कोरोना का टाइम है तो आप मास्क को ले लीजिए, मास्क को जब हम लोग दोनों तरफ खींचेंगे तो ये क्या होगा, मतलब एक्स एक्सिस में क्या होगा, बढ़ेगा, लेकिन एट द सेम टाइम जो अदर मतलब वाई एक्सिस और जेड एक्सिस है उधर हम लोग क्या होगा, कम होगा. सो दैट इज द लेटरल स्ट्रेन. बाय लीनियर स्ट्रेन इज नथिंग but it is termed as Poisson's ratio. Now lateral strain is Poisson's ratio is denoted as mu. So lateral strain is equal to minus mu into linear stress. Now here the terms come, why minus? My dear friends, I have told you that when you apply the tensile load on the x-axis, then there must be decrease in length from y-axis or z-axis. The y-axis and z-axis is nothing but that is lateral strain. So decrease in length indicates minus. So minus mu into linear strain. Here linear strain is nothing but we can also write it as longitudinal strains. So hope clear हो गया होगा ये कंसेप्ट, द लेटरल स्ट्रेन बाय लॉन्गिट्यूडनल स्ट्रेन. लॉन्गिट्यूडनल स्ट्रेन जो एक्स एक्सिस, अब मान लीजिए बॉडी को वाई एक्सिस की तरफ तान रहे, देन वाई एक्सिस में ज़्यादा होगा उसका लेंथ क्योंकि इलोंगेट होगा, एट द सेम टाइम एक्स एक्सिस और जो लेटरल जो अदर टू डायमेंशन है वहाँ पे कम होगा. अब अगर जेड एक्सिस में तानेंगे तो जेड एक्सिस में ज़्यादा होगा और वो दोनों तरफ कम होगा. ये हम लोग प्रैक्टिकल में भी देख सकते हैं, ऑल मटेरियल में ऐसे ही होता है. नाउ here the terms, this is very important, the relation between the Young's modulus and the bulk modulus. Here this one is very important according to the university perspective point of view. There are the numerous times these questions are asking, so the relation between Young's modulus and bulk modulus. So let us start. My dear friends, imagine that A, B, C, D, E, F, G, H is a solid cube. Here we are dealing about the relation between Young's modulus E and bulk modulus K. So I have told you that in the bulk modulus the normal stress is acting on each faces. So let us start. B, C, G, F is a x-axis planes in which sigma is denoted or the sigma is acting perpendicularly in x-axis. Similarly, A, D, H, E is also subjected to x-axis normal stress. The normal stress which is perpendicular to the A, D, E, H. Similarly, similarly the normal stress is perpendicular to the y-axis in upward and downward. Similarly, in z-axis, that is passing through the D and upward. So in the above figure it is clear that all the normal stress are facing all the faces of the rectangular cube. So if the solid cube is subjected to tensile stress, here we are applying tensile stress, but you can also apply the compressive stress. It's depend on you. So I have undertaken here the tensile stress. So once again, a solid cube is subjected to tensile stress in all the faces, x, y, z, in all the faces of the cubes, equal in all the sides. So direct stress, we know the simple stress is equal to simple strain. So or the direct strain is equal to shear stress by Young's modulus, and it is sigma by E, that is nothing but the direct strain. How much strain it is taking place? So lateral strain is equal to minus mu into sigma by E. I have already described it above. So here the direct strain is sigma by E and the lateral strain is minus mu into sigma by E. So net tensile strains produced in each sections will be sigma by E minus mu into sigma by E x in y axis. Similarly in z axis, I have told you that when the body is subjected to push or pull forces in one directions, either in x, then there must be lateral direction in other two. अगर x axis के तरफ body को खींच रहे हैं, then x axis में body का length बढ़ेगा, at the same time वो दोनों में कम होगा. So the net tensile stress in each direction equal to sigma by E minus other two. क्या y में क्या होगा, mu into sigma by E lateral strain minus mu minus sigma by E, that is lateral strain in z axis. So the net tensile stress is denoted as change in length by original length, that is net tensile strain. Change in length by original length, यहाँ से mu by E कॉमन आएगा, तो बाकी रह जाएगा 1 माइनस प्लस तो -2 mu, यानी कि सिग्मा बाई E into 1 minus mu. ये यहाँ से चेंज इन लेंथ हम लोग को पता चल गया. Now we will turn or we will talk about the volumetric strains. Now my dear friends, we all know that the original volume of the cube is LQ. So if dl is the change in length, then dv is the change in volume. So change in volume differentiate the original volume with respect to L. So dv by dl. So dv is equal to, if you differentiate L cube, then it must be 3L square dl, as we know how to differentiate. So if you differentiate the L cube, then 3L square dl. Now dv equal to 3L square dl. Now divide these equations with original volume. So dv by v equal to 3L square dl by L cube. So L square L cube cancel, then dv equal to dv by v equal to 3 del L by L. Now we know that the value of dl by L, that is change in length by original length, we know the value. So substitute that value in this equation. So dv by v is equal to 3 sigma by E into 1 minus 2 mu. And we know that what is bulk modulus. We know bulk modulus is nothing but the ratio of normal stress acting in all phases to the change in volume. Volumetric strains, and volumetric strain is nothing but the change in volume by original volume. So bulk modulus is denoted as capital K. Capital K is equal to normal stress by dv by v. Here capital K sigma by change in volume by original volume from the above equation, 3 sigma by E into 1 minus mu. So sigma sigma cancel. Finally K is equal to E by 3 into 1 minus mu, and E equal to just means do the cross multiply and replace. E is equal to 3K 1 minus 2 mu. So the relation between Young's modulus and bulk modulus is E equal to 3K 1 minus 2 mu. Remember in mind, in multiple questions is there is a certain types of numericals or direct formula may be given, that what is the relation between Young's modulus and bulk modulus. Then Young's modulus E equal to 3 times of bulk modulus into 1 minus 2 mu. Or if you need to find the Poisson's ratio, then mu is equal to 3K minus E equal to 6K. So here in this lectures we study the simple stress strains, types of stress, types of strain, and the relation between Young's modulus and bulk modulus. So I hope आपका ये वीडियो पसंद आया होगा. अगर आप इसी तरह आगे भी पढ़ना चाहते हैं देन चैनल को सब्सक्राइब कर दीजिए, लाइक कर दीजिए और शेयर करना मत भूलिए. And we will update the next video in the as per the time required to be updated. So wait for the next video and wait for the next lectures. Thank you so much. Hope you guys understand these ones and take care. Stay happy. Bye.